Hi, I'm John, your concierge to the world of the Raspberry Pi Pico, IoT, robotics and other fun tech. Today I'm going to look at the setup for C and C++ development for the Pico from the Raspberry Pi 5. I sell several courses on Pico development over on the Udemy platform. I've had some reports of issues of those choosing to develop on the new Raspberry Pi 5. So having at last got hold of one, I thought I'd take a look. In this video, I will look at both Raspberry Pi OS, Bookworm, and Ubuntu 23.10. I'll focus on the pinch points in development. Please remember to like the video and subscribe. I really do appreciate it.
In this video, I'm going to look at both Raspberry Pi OS and Ubuntu, both 64-bit ARM versions for the Raspberry Pi 5. Now, of course, both of these got fairly major updates in December. Bookworm for Raspberry Pi OS actually doesn't have an end date on it, so it is a longish term release as far as we're aware at the moment. The Ubuntu version that supports Raspberry Pi 5 is 23.10, and that does have a life expectancy of only until July. So there's not much life on it, but we do have 24.04 coming soon, and I'm really looking forward to that. So let's have a look at how both of these work against a Pico and in Pico development. This video is sponsored by PCBWay. PCBWay helped me out with the production of PCBs. They strive to be the most professional PCB manufacturer for prototyping and low volume production work in the world, which makes them a go-to place for makers like me, as not only do they offer quick turnaround on PCBs from their own in-house production services, they can also assemble the PCBs too. They can help with the project hardware too, through 3D printing, CNC machining, sheet metal work or injection molding. Get some inspiration from their community project site, or buy some ready-made modules from the module store. Go take another look at PCBWay today. I installed the Raspberry Pi Pico toolchain on Raspberry Pi OS using the quick start approach, so downloading picosetup.sh. I tell it to skip VS Code because I don't generally use VS Code. Generally, especially on a Pico, I use other approaches and probably edit the code remotely on my Mac. I then made the Pico setup executable and ran that, and it worked absolutely fine and installed flawlessly on Raspberry Pi OS. As commonly, doing this on Ubuntu is a little bit more tricky. So you need 2 additional packages to make this quick start setup guide run properly, and you need to have installed the raspi-config, because at the end of this setup it's going to try and turn on some UART configuration to allow you to do UART communication to your Pico. You also need pkg-config. This seems to give you the libusp and a few other dependencies, and without that Pico setup will actually fail, and some of the builds it does during its installation will fall over. Again, I'm skipping VS Code because I don't want that installed, and it's normal. Changes configuration and to executable and run it. I did some project build tests on both platforms, and both built perfectly. All the CMake compilers, linkers, etc. were all working perfectly. And then I used bootsel to copy the binary, the UF2 file, over onto my Pico. And I did that again from both operating systems, no problem. The PicoW and Pico were recognized perfectly as bootsel devices. I ran into a few problems when I started using a debug probe, and these were on both Raspberry Pi OS and Ubuntu, which surprised me a little because I'm sure I hadn't seen these problems certainly in the most recent versions of Raspberry OS and Ubuntu. I do remember having communication problems and issues back when we were on version 20.04 of Ubuntu, but I thought they'd all been fixed in 2204, so I was a little bit surprised to find them back again in 2310. But anyway, the problem is with the CMIS device that a debug probe is now, not being recognized by the OS and not therefore knowing what to do with it and what permissions to grant it in order to be mounted as a device. This can be fairly easily fixed by actually creating a udev rule. And that's really what is missing. There just isn't a udev rule associated in the standard rules. So I've created one. So in the folder etc udev rules.d, I created an at-pico.rules file, which has that line there, system USB, with all of the magic codes to recognize a Raspberry Pi debug probe and get that configured and available to use. So I can show you this on the system as well. So if we become root, because we need to be root to get into this location, we can change into etc udev rules.d, and you can see in there my Pico rules, and there we go, and there's the magic file and magic numbers that we need to make this work. And with that, you can actually happily program your Pico. Though I've flashed the Pico from bootsel approach and using a debug probe, I must admit I haven't tried using bit bashing across the GPIO, mainly because very few people seem to do that anymore. Now that we've got debug probes, that tends to be the way people go, and using that bit bashing approach on the GPIO pins, which always was a little bit brutal and a little bit subject to impacts of what else was going on your Raspberry Pi, people are not doing that so much. Are you still using the bit bashing approach? If so, let me know. I'd be really interested.
Finally, if you're running the debugger on the Raspberry Pi, you should also use GDB multi-arch from now on. Most of the other platforms like Mac and Linux have already moved to this, so not surprised to see the Raspberry Pi follow suit. It looks to me like both Raspberry Pi and Ubuntu had to rush the release to hit the Raspberry Pi 5 release dates. Why else have we gone back in support for CMSIS devices like the Raspberry Pi debug probe? I'm certainly hoping that Ubuntu 24.4 fixes this and makes the setup of a Pico development environment more straightforward. If you're thinking of getting started with Pico development, please do take a look at my introduction course on Udemy. You may find it helps you get up and running much more quickly. Thank you very much for watching. Please like the video as it helps others find it. And please subscribe and hit that notification button so you don't miss the next video. Goodbye for now.